Welcome to the Explainer. Today we're diving into Mathematics Form 3, Chapter 5, Trigonometric Ratios. Now look, I know for a lot of students, the second letters start mixing with numbers inside a triangle, absolute panic sets in, right? But I promise you, by the end of this Explainer, we're going to transform that intimidating right-angled triangle from a confusing, jumbled puzzle into an easy-to-master toolkit for your exam revision.
Okay, let's dive into this. Here's our roadmap so you know exactly how we'll build this up. First, meet the right triangle. Second, the magic codes, TOA, KA, SO. Third, solving the triangle mysteries. Fourth, special angles and surds. Fifth, degrees, minutes, and calculators. And finally, number 6, your trigonometry toolkit. All right, let's jump straight into section 1. Meet the right triangle. Before we can pull off any math magic, we really need to understand the stage we're working on, right? The right-angled triangle is basically the main character of this entire chapter, and getting to know its parts is absolutely non-negotiable. Our anchor point here is the hypotenuse. It is always the longest side, and you're going to find it sitting directly across from that 90-degree angle. So, a pro tip for you. Whenever you look at a brand new triangle problem, find the hypotenuse first. It literally grounds everything else we're going to do. Now, while the hypotenuse happily stays put, the other two sides are kind of like shapeshifters. We call them the opposite side and the adjacent side. But here's the trick, and you gotta remember this. They change based entirely on the position of the acute angle you're actually looking at. So if you're referring to one specific angle, the side furthest away is the opposite, and the one right next to it, well, that's the adjacent. But if you change your angle, yep, those labels completely swap. Moving right along to section 2, the magic codes TOA, CAH, SO. And this brilliantly illustrates where we take those three sides, hypotenuse, opposite, and adjacent, and create the core tools you need to unlock any triangle's secrets. Seriously, I want you to burn this massive mnemonic into your visual memory. TOA, KA, SO. Say it with me in your head. If you can just remember these three weird nonsense words, you can practically solve any basic trigonometry problem. It's a real game changer. So let's break down exactly what TOA, CAH, and SO actually stand for. They're simply predictable relationships between the sides of the triangle. So SOH, that means the sine ratio is the opposite side over the hypotenuse. CAH means the cosine ratio is adjacent over hypotenuse. And TOA means the tangent ratio is the opposite side over the adjacent side. It's just a simple, perfect system for solving these spatial mysteries. But wait, there's actually a hidden layer here. Tangent doesn't just relate to the sides. It relates directly to sine and cosine. The golden rule here is that the tangent of an angle equals its sine divided by its cosine. Think about it. If an exam question tells you the sine is 0.6 and the cosine is 0.8, you don't even need to know the triangle's actual side lengths. No way. You just divide 0.6 by 0.8 and boom, your tangent is 0.75. Just like that.
All right, let's put this into practice with section 3, solving the triangle mysteries.
Now that we've got our toolkit packed, let's methodically apply it to some actual worked examples, just to see how this plays out in a real exam scenario. More often than not, a triangle is going to be missing a side. Here, we need to find the hypotenuse, which is labeled PR, and we're given the other sides as 15 and 8 centimeters. So, what do? We pull out our trusty old friend Pythagoras' theorem. Step 1, we take the square root of 15 squared plus 8 squared. Step 2, we calculate those squares to get the square root of 289. And step 3, we solve it to find that PR is exactly 17 centimeters. Let that math sink in for just a second. Find the missing side first, and I promise you, the rest is a total breeze. Because once we have all three sides, 15, 8, and our shiny new hypotenuse, 17, finding the ratios is literally just a matter of plugging numbers straight into our TOA, CAS, SO formulas. So for angle PRQ, sine is opposite over hypotenuse, right? That's 15 over 17. Cosine is adjacent over hypotenuse, which gives us 8 over 17. And if we switch our perspective to angle QPR, well, tangent is opposite over adjacent, giving us 8 over 15. Easy, right? Let's move to and see how this builds when we actually have to work backward. Imagine we're given the sine ratio of 3 over 5, and we know the hypotenuse is 20 centimeters. But, plot twist, we need to find the opposite side, QR. Okay, step 1. We set up the equation. QR over 20 equals 3 over 5. Step 2, we do a little rearranging. QR equals 3 times 20 divided by 5, which brings us perfectly to step 3. QR
is 12 centimeters. Section 4, special angles and surds. Okay, get ready because now we are officially elevating you to ninja level math. We're going to look at 30, 45, and 60-degree angles, and we're going to do the whole thing completely without a calculator. To pull this off, we need to talk about surds. Now, surd is just a fancy, slightly intimidating word for a very simple concept. It's an irrational number that's just left in its root form. So instead of writing out some super long, messy decimal, we just write square root 2 or square root 3, which you'd read out loud as surd 3. Takes the pressure right off, doesn't it?
Let's use this in an actual calculation directly from the source material. We want to add sine 45 degrees and cosine 45 degrees. The exact value for both of these is 1 over surd 2. Adding them together gives us 2 over surd 2. But mathematicians, yeah, we really don't like having roots in the denominator. So in step 2, we use a very specific technique. We multiply the fraction by surd 2 over surd 2. This neatly turns that bottom part into a regular old 2, which allows us to just cancel it right out, leaving us with a beautiful, clean final answer in step 3, just surd 2.
Moving on to section 5, degrees, minutes, and calculators.
All right, let's transition from the pure exactness of surds back to practical real-world calculator applications and those finer units of measurement. Here is a totally surprising fact about measuring angles. When we need to be way more precise than just a whole degree, we break it down into minutes and seconds, literally exactly like a clock. 1 degree equals 60 minutes, and 1 minute equals 60 seconds. It elegantly connects how we measure physical space directly to how we measure time. Pretty cool, right? Now, converting between these forms is a two-way street you really need to grasp for your exams. On the left side, we're converting a decimal into minutes. So 30.2 degrees is 30 whole degrees plus 0.2 times 60 minutes, giving us exactly 30 degrees and 12 minutes. Over on the right, we're going backward. If we have 43 degrees and 30 minutes, we just divide that 30 minutes by 60 to get half a degree, which results in 43.5 degrees. Once you get the hang of it, it's super straightforward.
But, up to now, we've had the angle and we've found the ratio. But what if we have the ratio? Say we know the sides of the triangle and we need to find the exact angle inside. How do we work that magic? So, the crucial point is knowing exactly how to use the inverse functions on your scientific calculator. Let's say sine x equals 0.8377. To find x, you punch in inverse sine of 0.8377. Your calculator basically works completely backward to reveal that the angle x is 56.9 degrees. Or if we use our new clock trick, 56 degrees and 54 minutes. And hey, the exact same logic applies to tangent. If tan x is 2.4876, hitting inverse tan gives you a 68.1 degree angle. And finally, section 6, your trigonometry toolkit. Wow, okay, we have covered a ton of ground today, right from the basic anatomy of a triangle all the way to complex calculator conversions. So let's wrap this up with your absolute core takeaways for your exam revision. First, memorize toa kaha so. It is quite literally your ultimate key. Always remember that sneaky hidden rule, tangent equals sine over cosine. Keep in mind that 1 degree behaves just like an hour, splitting into 60 minutes. And when you're faced with any triangle problem, always use Pythagoras to find any missing sides before you try doing anything else. With these tools firmly in hand, ask yourself, are you ready to tackle those Form 3 exam mysteries? I think you definitely are. Keep practicing, and I'll see you in the next explainer.